Okay, we had a little tech problem, so this is going to be in part 1 and part 2. So when you get this, watch this one first and then watch the second one. Okay, I just want to review equal subintervals. I want to talk about rectangles and trapezoids. I know we just had this on the test, but I want to just talk about something else. So if you do the left or the left rectangular approximation method, it's width times length. The widths you can see are all the same. They're all 2's. And then if you do the left, you take all the numbers except 3.8. And when you add that up, oh, I didn't add it up, sorry. But that's how you do the left one. Again, review trapezoid. It's 1/2 height, base 1 plus base 2. And again, it's 1/2. The heights are all 2. And when you do this, it's 0, and then you double the 0.6. You double the 0.1 or 1.4, and so on, until you get to the single 3.8. Okay, those are just review. I know we just had this on the test. Okay, now I want to talk about, I showed you how to do the trapezoid. I showed you how to do the left. You can also do the right. You can't do the midpoint by using intervals of 2. You can't do the midpoint because if you take the midpoint of 2 and 4, what's the midpoint of 2 and 4? Isn't it 3? And 3 is not on there. But you can do the midpoint if you change your interval. So, as you can see, how many intervals did we start with? 1, 2, 3, 4, 5, and 6 intervals. But now, if we change our interval, I'm going to erase that. If we change our intervals, and instead of going from 2 to 4, we go 2 to 6, 6 to 10, and 10 to 14, they're still equal, aren't they? From 2 to 6 is the first interval, 6 to 10 is the second, and 10 to 14 is 3. So instead of using 6 intervals, like we did up here, I'm only going to use 3 intervals. And I'll show you how you can do midpoint now. So, if you do 3 intervals and you do endpoint, do you see that when you do 3 intervals that they are equal distance 4 apart? So I'm going to put a 4 on the outside, which stands for the width. And then, if you're doing midpoint, what's the midpoint between 2 and 6? Isn't it 4? And then you look at what the 4 is, and isn't it 0.6? And then the interval between 6 and 10, isn't it 8? And then you look down here, and isn't it 2.7? And then the last interval is between 10 and 14. What's half of 10 and 14? And right in between is 12. You look down at the y value, it's 4.1. So if you change the interval, you can do the midpoint. You can't do it if it's 6 intervals, but you can do it if it's 3 intervals. Just to keep in mind. So that's something new. Okay, something else new, which will be on the AP test. Most definitely, you will see this on the AP test. It's not in the book, and that's why I'm showing you this today. So, how do you do it when they're not equal? What do I mean by not equal? Look at your x values. Do you notice that there are 1, 2, 3, 4 intervals? You can see that there are 4 intervals, but do you notice that these intervals are not the same? From 0 to 2 is 2, 2 to 3 is 1, 3 to 7 is 4, and 7 to 9 is 2. They're not equal. So how do you do not equal? Well, if you're doing the left Riemann son, you're using rectangles, correct? Same thing with this one, you're using rectangles. And you know the formula is width times length and width times length. But do you remember, I'm just going to go back to the last page. If you go back to the last page, we just stuck the width out here because the width never changed. And all of these right here are all the lengths, right? Now, since the widths are not all 2, you have to do each one separately. So I need to figure out the first W times L, and then the next W times L, and then the next W times L, and then the last W times L, because there are 4 intervals. So This is what you have to do on the AP test if they're not the same. The widths are 2. 0 to 2 is 2. The lengths, if we're doing the left one, we take the 3 plus the next width is between 2 and 3, which is 1, and then the next number you pick is a 6 plus the next width is 4, and the number next to the 6 is 7 plus the next number width is 2, and the last length you pick is 6. This number 8 does not get used because you're doing the left Riemann sum. And the answer to that one, if you add that all up, adds up to 52. Okay, it's the same concept with the right Riemann sum, and I'll do one more. Again, if you do the right one and it's unequal, you have to do WL plus another WL plus another WL plus another WL. So the W's are all staying the same. Whoops, I'm going to make that a 1 with a parenthesis plus a 4 parentheses plus a 2 parentheses. Your W's are all the same intervals. But now if you're doing the right, instead of not using the 8, you are not going to use the 3. So you're going to cross off the 3, and the first number would be a 6, the next one would be a 7, the next one would be a 6, and the last one would be an 8, which would give you 59 for your answer. Okay, back to this again. How do you do the trapezoid on unequal? This is the one I think you're going to see on the AP test. You know the trapezoid is 1/2 height, base 1 plus base 2. But since it's unequal, you have to do the same thing like you did in the left and the right. You need to write out the formulas for each one. So I'm going to start with the first one and go 1/2. And if you look at the first one, the height is the same thing as the width, so isn't it 2? Plus 1/2, I'll come back to those. If you look at the next one, the height is 1, plus 1/2. It's the same as these up here. I'm just going to circle that. I use the width is, and the heights are all the same. And the 1 and the 1, so this is a 1, and the next one is going to be 4. And then the last one is going to be 1/2 the height, which ends up being 2, and parentheses. This might be an aha when you look at this, but when you do the trapezoidal, which is between 0 and 2, the height is 2, I need to take 3, and that would be base 1, and this would be base 2, which is 6. Okay, the next one, if you want to take between 2 and 3, you have to take base 6 and base 7. Okay, and then the students figured out something that, as you can see, the 3 only gets used once, and guess what? The 6 gets used on this trapezoid and 6 on this trapezoid, and that's why you have to double it. And then we can continue this. If the 6 and the 7 gets used on that one, the third interval, the 7 and the 6 gets used. And on the last the 6 and the 8. And as you can see, all the middle numbers got doubled except the end number. The 3 and the 8, you look down here, there's only 1 3 and 1 8. But if you look at the rest of them, there are 2 6s, there are 2 7s, there's another 6, and that's why they get doubled. And the answer for this is 55.5. So this is part 1 on unequal intervals. Now continue to part 2.